alternatives come with a price as well. And it comes down to the fact that if you can't grow it, you have to mine it out of the ground. And if you look around the room at the things in your pockets and the things that are making up this room, everything here that didn't grow as a tree has to be removed from the earth, and it's going to cause some impact to the earth. And so we need to think about how best to do that well. So I want to begin just by talking a little bit about the scale of the problem that we face, and then talk about a specific project that we're working on here in North Carolina on battery manufacturing. So this is just a look at the periodic table of elements with the sources of these elements that and where we're getting these elements worldwide. And you'll notice when you look at this chart that there's some problem areas here, that nations that we're not exactly getting along with right now, and nations that are not exactly extracting things from the environment environmentally sensitively, are providing big chunks of the resources that we need to make our EVs, to make our phones, to make our computers, to make all the things that you see running around this room. And the problem gets even bigger when you start looking at reliance in the US on imports. This is a problem for us economically and geopolitically. We're reliant on these nations right now for all of these things. And when Russia invades Ukraine, for example, we all of a sudden run out of a lot of different parts of the periodic chart that we don't have access to here in the United States. So it's a problem for us as a country in these so-called critical minerals. The problem becomes even bigger when you think what it takes to extract these different things out of the ground. And this is just a ratio of how much rock has to be removed from the ground to get one part of the element that you're interested in. And some of these aren't so bad. Some of these aren't so bad, but there are other parts of the periodic chart where you have to remove an incredible volume of rock from the earth in order to get a usable volume of the commodity, the critical mineral that you're interested in. And this is the way the geologists are thinking about the problem. I think really relevant to this discussion here today is how well we're reusing that material once we've taken it from the ground. When we have a fossil fuel and we burn a fossil fuel, it goes off into the air as carbon dioxide, carbon monoxide, water, and we're never going to see that again. That's not true of these elements that we extract from the ground. This is not alchemy. Once we extract a mole of lithium, a gram of lithium out of the ground, it's always going to be lithium. And so if we focus our efforts on recycling that lithium, every gram or most of every gram of lithium that we extract from the ground can be reused, and it will always be lithium. So this is a really important part of the sustainability of the geology that we're exploiting. So the United States Geological Survey is involved in a huge project all across the United States in critical mineral resources. They're remapping a lot of the United States, and they're evaluating every square inch of ground for its critical mineral potential. And my lab is involved in some projects in that here in North Carolina, and I want to talk with you about North Carolina's potential here. And I think we've all heard, most of us has heard, that Toyota broke ground very recently on a huge battery manufacturing plant just west of here. I drive by it a lot on my way out to the mine that I've been working at. And it's no accident that Toyota chose North Carolina for this plant. Probably there was quite a bit of economic incentive. But in addition to that, lithium batteries, one of the great lithium batteries are lithium phosphate batteries. And it turns out that in North Carolina, we have two of the critical components to make lithium iron phosphate batteries. The first one is kind of fun. Anybody that's collected a shark's tooth off the coast of North Carolina, that's calcium phosphate. And Aurora, North Carolina is a great source for phosphorus for making lithium iron phosphate batteries. It's underappreciated at this point, I think, but these guys are also a really good source for rare earth elements, and I can see going down in the future that they're going to be exploited for rare earth elements too. We don't need to throw everything away after we've extracted the phosphate. We can get the rares as well. In addition to the phosphate, the Kings Mountain area of North Carolina has been historically mined for lithium, and there are presently tens of billions of dollars of lithium hypothesized or known to be under Gaston County, in that area in North Carolina. Kings Mountain was historically mined for lithium in the 20th century. In the late 1920s, this is an open pit mine that was open from the late 1920s until 1989, when we didn't need much lithium at the time in 1989, and the prices in China put the mine out of business. So this is an open pit mine that's been sitting idle since 1989. And one of the things I'd like you to take away from this is that once we walk away from this open pit mine, nature has recovered it rather nicely in North Carolina. So this is a habitat now for geese and such, yeah? And it's a nice place, and it's only 30 years out from active mining here. So there is potential once we abandon these sites, if we handle them properly, we can turn them into useful things. So Kings Mountain is being reoccupied by Albemarle Mining, and they hope to begin extracting lithium again from the mine at Kings Mountain. The first thing they're going to have to do is drain that pond, which is going to be a really interesting environmental problem for geologists and people like you to think about. But this is a tiny spot in the lithium potential in North Carolina, and the rest of the area that has lithium potential in North Carolina looks like this. It's farmers' fields, it's homes, it's people's private land, and it's being explored and purchased by another company, Piedmont Lithium, and they're the ones that have estimated tens of billions of dollars worth of lithium in the ground here. So we're left with an economic and personal conundrum here, because if you drive around the same area, you see a lot of signs that look just like this. But we have to ask ourselves a question: if we want lithium batteries, if we want EVs, if we want this battery plant in Winston-Salem, we need to think about, we've got to pay the price. We can't just make it out of the air, okay? And so I'm working through funding with the NC Policy Collaboratory on exploring this, and I'm hopefully working with the mining companies to improve exploration technology so that we can minimize that environmental footprint and that environmental impact, but take advantage of the strict laws that we have here in the United States and do this responsibly so that we're making these EVs and we're not destroying the planet some other way.
Thank you, Drew. So are there questions for Amanda and Drew to start? And we can also pretty quickly move on to a broader discussion as well. But let's start with Amanda and Drew questions. Yes.
I guess one thing, I'm wondering how easy it's been to acquire these private lands. Like, are people giving it up relatively easy? Or?
Yeah, so Piedmont is purchasing the land. Their initial offer, they've gone in and offered twice the listed value of the property, and they've acquired most of the property that they need. There's still some holdouts, although as more and more of the property around you is purchased and you're this island, you get less incentive to hold out. The biggest thing that's stopping things right now is just getting public approval for permits to actually start doing the work. It's moved from the geological, we know it's down there, we know where it is. They've got a plan for getting it out of the ground. It's up to Raleigh now, to Gaston County and Raleigh to work out the politics of getting it.
Thanks. Some questions also about the mining. So do you know if there's any policies that allow Gaston County or the state of North Carolina in general to gain some of that financial incentive from the mining, and also to ensure that the mines will be abandoned responsibly?
I'm not a politician, so I don't know. I know that the company Piedmont is going to build a lithium processing plant across the state lines in Tennessee, and that raised the attention of the people in Raleigh because they want that plant here in Gaston County, and there's lots of incentives for it through the Infrastructure Act. To get it. So other people who may be more political may be able to answer, but I try to keep myself out of such things. I like rocks.
Yeah, that was a super interesting chart you showed, the periodic table with how the percentage of recyclability of different metals, and I was just wondering, how much does like the persistence of different metals affect the recyclability? Because it looks like a lot of the ones that are key for clean energy technologies are pretty low in terms of the recycling rate, but they might have potential.
Yeah, I think there's a lot of potential. So one of the things that I'm most excited about Albemarle and Piedmont is they're both attacking more than just getting the lithium out of the ground. Albemarle just built a multi-million-dollar, incredible, dream-worthy lab, which has the sole goal of increasing recycling potential for the lithium and increasing battery efficiency for the lithium. So they're investing all this money on the life of lithium. In contrast, Piedmont is going to, their plan is to build, to power their whole operation solar. They've set a huge chunk of the property aside where they can build a solar farm. There are going to be no trucks on the property. Everything's going to be moved by an electric conveyor belt system. Their goal is to process everything from raw rock down to lithium hydroxide, which then can be shipped directly by rail to Winston-Salem for making batteries.
Zara.
I'm going to stay on rocks. But
I like it. That's where I feel most comfortable.
lithium in North Carolina. Could you put those numbers in perspective in terms of how much of lithium, just relatively, at a big picture level, compared to what the US has?
Yeah, so as far as the US, this is our best shot. So the problem is we're not brine lithium. This is hard rock lithium, so it's in a mineral called spodumene. It's a lithium aluminosilicate, so the processing is a bit more energy intensive and a bit more difficult, but there's so much of it down there that, and the goal, both Albemarle and Piedmont, I think ultimately hope to use North Carolina and or Tennessee to bring their hard rock spod from around the world to process and turn it to lithium hydroxide. Yes.
Also on the concept of mining, so you said that the big battery that most EVs are using right now are lithium iron phosphate.
That's my understanding, but Noah can probably answer better.
Well, actually, I think those are more for stationary grid batteries, but yeah, they're a version of lithium batteries.
Lithium batteries, right? So, is there any? Do you know of any like other advances in other types of metals that EVs can be starting to use, like rather than lithium?
Not me personally, but
People used to talk about nickel metal hydride, but those aren't nearly as efficient and don't have the lifetime as lithium. Lithium is pretty good and cheap.
yeah. And but the cyclability of lithium batteries is really good, I think. So cobalt too, I think, was popular for a while, but it's falling out of favor a little bit.
Any other questions? All right, so far, we're not going to have a huge formal setup for our discussion. Amanda, I have a question for you. The data you gather, does it allow you to project forward for future land use change and future climate change, like temperature and stream flow and things, or is that a different exercise?
Our first step, I think that we're still a few years away from, is testing how well we can interpolate, and then I think our next steps will be testing how well those models work for actual prediction.
Yeah.
So we're a long way from that.
Yeah.
But,
Thank you. Other questions? Noah?